I am incredibly excited to welcome you to today's Explainer, where we get to announce the open-source release of the Agent Witness Protocol, or AWP. It's a brand new standard built specifically for the agentic AI era. We're going to unpack exactly how this works, so if you've been wondering how we're going to maintain trust as AI gets more and more autonomous, you are in the right place. To truly understand why AWP was created, we really have to look at one critical, high-stakes question. As AI agents begin to pay, sign, approve, and generate content autonomously, how do you prove what an AI agent actually did to someone who wasn't there and has no reason to trust you? Think about it. If an agent executes a financial trade or issues a refund, and a dispute comes up, how do you cryptographically prove the exact actions that agent took?
Okay, let's dive into this. Here's our roadmap. We'll start with the AI trust problem, meet the Agent Witness Protocol, and then look at its honest 80-20 architecture. After that, we'll peek inside the witness record, unpack its typed honesty boundary, and finally talk about trusting the agentic era.
Part 1. The AI trust problem. So the fatal flaw in today's high-stakes AI landscape is basically this. Logs live inside the system that produced them, right? To check those logs, you essentially have to blindly trust the operator. Traditional logs completely lack portability, and you can't independently verify them. If a massive tech company's autonomous AI takes an action, just telling users, hey, trust us, simply doesn't cut it anymore.
Section 2. Meet Agent Witness Protocol.
AWP is the definitive, cryptographically secure solution to this exact problem. It introduces the witness record, which is a cryptographically verifiable, tamper-evident receipt of a governed agent event, re-verifiable completely offline. Basically, you can think of AWP as a tamper-evident retail receipt for an AI's brain. It's a highly structured, signed record of exactly what happened, and you don't even need an internet connection, let alone permission from the AI operator, to verify that the record hasn't been messed with. Let's look at what this witness record actually captures about an autonomous action. First, it logs the intent: who acted, what verb they used, and what the target was. Next is the authorization, meaning the specific credential that permitted the action. This next part is absolutely crucial. Artifacts are referenced strictly by hash, never by their actual content. That protects sensitive data. And finally, verifications, which capture the witness's own typed testimony about the external things it checked.
Section 3. The honest 80-20 architecture.
And this brilliantly illustrates the philosophy of AWP, composition over invention. It explicitly avoids inventing new, untested cryptography. Instead, it adopts 80% proven open standards. For the signed envelope, it adopts DSSE and in-toto. For the transparency log, it uses the RFC 9162 Merkle subset. Checkpoints use C2SP, and time anchors use open timestamps or RFC 3161. Oh, and standard ED 25519 signatures are utilized too. It's seamlessly pulling together the absolute best existing security standards we already have.
But the true innovation of AWP is the 20% it uniquely adds. We call this the 20% moat. This consists of a neutral third-party witness topology, typed honesty boundaries, and verified human authorization. The secret sauce isn't in the cryptographic envelope bytes themselves. It's the fact that it establishes a truly independent, neutral witness that is fundamentally decoupled from the agent's operator.
Section 4. Inside the witness record.
Let's walk through how this actually works in practice with the 4-layer offline verification chain. It starts with the signed envelope, moves to the transparency log inclusion proof, then hits the checkpoint, and finally the time anchor. By walking this exact sequence through a command line interface, anyone can independently verify the receipt bundle end-to-end, and I cannot stress this enough, this requires zero network access and absolutely zero trust in the system that produced it.
It takes exactly one flipped byte, literally just one altered character anywhere in this entire chain, and verification completely fails. Because of how the architecture is designed, the verifier explicitly names the exact broken layer. It fails closed, ensuring that tampering is immediately undeniably obvious.
Section 5. The typed honesty boundary.
This next part is AWP's most radical design decision. It builds immense credibility by highlighting exactly what the protocol limits itself from doing. On one hand, AWP proves integrity since witness and provides tamper evidence. But on the other hand, it explicitly does not prove authenticity at origin, the true identity of a person or completeness.
meaning proving a document hasn't been altered since the witness saw it says absolutely nothing about whether it was a forgery to begin with. This radical transparency isn't just a promise in the documentation, it is literally hard-coded into the software. Every single time you run a verification report, it outputs this exact quote. AWP verified proves integrity since witness only, not completeness, not authenticity at origin, not the identity of any person. It makes overclaims grammatically impossible in the code itself. If a record tries to claim it magically verified a human's identity, the system just rejects it outright.
Section 6. Trusting the agentic era. Now, what's really interesting here is how AWP handles the future threat of quantum computing with a really pragmatic, additive hybrid model. It introduces experimental MSDSA 44 signatures right alongside standard ED 2559 signatures. The classical signature is always required, which means existing receipts will never break, but it provides this verifiable post-quantum backstop using NIST standardized FIPS 204 naming. It's totally crypto-agile.
Beyond the math, AWP is practically ready for real-world compliance, like the upcoming EU AI Act. High-risk systems will require automatic tamper-evident event logging between 2026 and 2027. AWP's architecture cleanly and natively maps onto these exact requirements. Things like start and end timestamps, system identity, and governance decisions map perfectly onto Article 12 of the EU AI Act.
And why does this all matter for us? Because AWP is a fully open-source protocol utilizing the permissive Apache 2.0 license, and it's published on a permanent neutral namespace at awp.dev. This empowers anyone to independently check hosted receipts. It guarantees that you are never, ever locked into some proprietary audit tool owned by a single corporation.
So I want to leave you with one final drop-the-mic question that really summarizes the stakes here. When autonomous agents run the global economy, who holds the receipts? We absolutely need an infrastructure of trust that doesn't rely on just taking a company's word for it. And AWP provides a compelling, mathematically sound answer. Thank you so much for joining me on this explainer, and I'll see you next time.